Question 8 is coming from quadratics part A. Express 3x squared minus 12x plus 14 in the form 3 into x plus a bracket squared plus b, where a and b are constants to be found. This one we can do it in two ways. Choose the one that is easier for you. The first one, I need to first get the coefficient, because here we are using complete squares. So the coefficient of x squared has to be a 1. So since it is not a 1, then I first factorize it out. Okay, I'm only going to deal with the terms that have got an x in them. So this one will be a 3. Then I have x squared here minus, this will be 4x. Remember, when you open, you still get the same thing. Okay, then plus the 14. Let me leave this one out. Now, we are going to get the coefficient of x here. We divide it by 2. So this negative 4 divided by 2, you get a negative 2. So I'll have 3 in here, then I'll have x, you get that negative 2. You put a square here, pop this one out, and then you square it, okay? So minus, then the 2 squared, and then plus the 14. So somebody can be asking, why are you doing this one here? This one, we get it from here. If I have, let's say, x here plus a, then squared. This is the same as saying x squared, then plus, when I expand, 2ax, then plus a squared. I need to have these terms that have got an x onto one side. So bring this one this side. That means you're going to have x plus a, okay, squared, then minus a squared. So we shall have x squared here plus 2ax. Do you see that? Now, I want you to look at what is happening here. The coefficient of x here is 2a. They divided it by 2. And then, after dividing it by 2, they put it here, they squared it, they also put it here. You see that? That's why I got the coefficient here, divide it by 2, you get negative 2. Put it here, and also put it here. Okay? So the sign that is actually here is the one you are going to put here. Whatever is here, the sign is always a minus. Why is it always a minus? Because you have seen from here, when I take this one this side, it becomes a minus. You see that? So that is what we are having there. Then after that, we can now open the brackets and then simplify. So this will be 3 into x minus 2, bracket square, then minus. This will be 4, then times 3, that will be negative 12. Then plus 14. So meaning our answer here is going to be 3 into x minus 2, bracket squared, 14 minus 12, that one will give us a positive 2. So that is that. Meaning A is negative 2, and then B is positive 2. Okay. Then, alternatively, you can do it like this. Alternatively, you can expand and then equate coefficients. So you can say 3x squared minus 12x plus 14. This one is the same as this one here. So let's expand. This will be 3. Inside the brackets, we have x squared, then plus 2ax, then plus a squared, and then plus b. So meaning this one is going to be, when you open the brackets completely, this will be 3x squared, then plus 6ax, then plus 3a squared plus b. Okay? So now what we do, we equate the coefficients. So the coefficient of x squared is this 3 here. Okay? Then we go to the coefficient of x here is 6a. This one is negative 12. So I will say negative 12 is equal to 6a. By dividing all through by 6, that means a is equal to negative 2. And then next we get the constant term, which is 14, which is going to be equal to what we are having here. That is 3, then into negative 2, the value of a squared, then plus b. So a negative squared, of course, that one will give us a positive. That will be 4 times 3. That will be 12. Then when you bring this one this side, it will become a minus. So 14 minus 12, then b becomes a 2. Okay? And then you can conclude and say that 3x squared minus 12x plus 14 is going to be equal to 3, then into x, what is your a? Is a minus 2. So minus 2, and then b is a positive 2. Don't get confused when they say plus a here, but then the value of a you get is a minus. These are just constants. A can be a positive, can be a negative. So that is that. Now they are saying that the function f of x is equal to 3x squared minus 12x plus 14 is defined for x greater or equal to k, where k is a constant. Part B, find the least value of k for which the function, the f inverse exists. Now, this one here being a U-shaped curve, okay? This one is a U-shaped curve. Actually, you get this one, you equate it to 0, by the way, there is a square here. You will get your x coordinate as a 2. Then when you put it here, of course, this whole thing disappears. This one becomes the y coordinate. Okay, so it is going to be 2, 2. This is the minimum point. Now, on this minimum point, the inverse, this function here, remember what they have given us here is exactly what we are having here. They are just simplifying our work by first giving us to put it in this format. Now, what you see here is exactly what we are having here. Now, the function has been decreasing. Now, when it reaches here, it turns off from there. Now, here, the way it is going, if we are having only real values, okay, all real values, that means two values of x here. Okay, there is an x value here, and then there is another one here. They all give to one same y value. Do you see that? That is now what we call many-to-one function. A many-to-one function cannot have an inverse, but a one-to-one function is the one that has an inverse. So what they do, they go to the turning point and then they choose one side, whether it is to the left or to the right. Okay. Now, here they have given us x greater or equal to k. And the least value for which the function has an inverse is that turning point here, that x value here you are having, which is a 2. So therefore, you just get that x is equal to equated to 0, and then your x becomes a 2. That means your k is going to be that 2. It is at that point where the curve turns from as simple as that. Okay, so now when they choose the right side this way, that means the function is going to be one-to-one, because it will be going for every one value of x, you get one value of y. Every one value of x, you get a unique value of y. So it becomes one-to-one. Therefore, it has an inverse. Okay, that is that. Now, when we come to this one here, for the rest of this question, you should assume that k has the value found in part B. Now they want us to find the expression for the inverse of a function. Now, suppose they had not told us to do this at first. That is the thing we are supposed to do first. But the way they set these questions, they simplify your work. Okay, you cannot find the inverse of a quadratic function in this expanded form. It has to be in the completed square format. Okay, so suppose my f inverse of x is equal to y. That means x is equal to f of y when you take the f this side. So that means I will go to the function. Wherever there is x, then I'm going to put a y. Okay, first of all, our f of x is the same as what we are having up here, 3 into x minus 2 and bracket square, then plus 2. So where there is x, then I can put the y. So we shall have 3 into y minus 2 bracket square, then plus 2. And then the next thing to do is to make y the subject of the formula. So bring this 2 here, then after divide by 3. So I will have x minus 2, then divide by 3. Then this one will be y minus 2 bracket squared. And then we take the square root. So when I take the square root, that will be a plus or minus, you know that, okay? Which is equal to now y minus 2. Then from here, take the 2 away. So that simply implies that y then shall be equal to, when the 2 crosses, it becomes a plus. So 2 plus or minus to the root of x minus 2 out of 3. So meaning the inverse of this function here is going to be 2. We don't know the sign. You're not supposed to put plus or minus, because remember, a function that has an inverse has to be a one-to-one function. Okay, and if you have been following me, I've always said that you look at the domain of the function. If they use the right side of the turning point, okay, then you take the positive. If they use the left side, let's say they use less than or less than or equal, then take the negative sign. So for this case, we are going to take the positive sign. So I will just come here and then I put a plus. But let me prove where this one is coming from. Okay, when I have a function here, then I have x values, then a function acts on it. Then what comes out is the f of x. This is the domain. That is the set of values you put in the function, the input. Okay, and then what comes out is the range. Now, the function that undoes what the function did is the inverse. So meaning, what you're going to put in this function is the domain. So this is the domain here. The range of f is the domain of the inverse. And then what you get out here is going to be the range. So the range of f inverse is actually the domain of f. You see that? Now, we have, based on what we are having here, they say that x, this function is valid for x which is greater or equal to this 2 here. Let's choose a value here. Let's say x is 3. Okay? So if x is 3, what is f of 3? F of 3, substitute in here. We shall have 3 into 3 minus 2, then squared plus 2. What do we get here? Of course, this one will be a 5. Okay, now what we have gotten out here is going to be the domain of the inverse. Now we are going to pick this 5 here, we put it in here, and we see whether we get the 3 here. So f inverse of 5, this one is going to be 2. Let me leave space here. Okay, we have 5, then minus 2 over 3. This one will give us 2, then the square root of 3 over 3. 3 over 3, that is a 1. So that means I will put 2, then 1. Now I'm asking you, for us to get a 3 here, do we put a plus here or we put a minus? It has to be a plus. Do you see that? So if I put a plus here to get the 3, then I'm going to put a plus here. But not to waste time with all of this. What you are going to do is to just come here. You look at the domain of the function. If they have chosen the side which is to the right of the turning point, then choose the sign as a plus. If they choose the side to be on the left of the turning point, then you are going to use a minus in between there where the square root is. So that is that. Hope I've made necessary noise. Part D, hence or otherwise, solve this equation here. First of all, we have our f of x here. This is a composite function. Put f into the f. Okay, f of x is 3 into x minus 2 bracket squared, then plus 2. I'm going to take this completed square form. Okay, now meaning f of x, it is going to be 3. Where there is x, we put f of x. Then there is a minus 2 here, then square, then plus 2. You see that? So we are going now to have 3. Now put f of x, which is 3 into x minus 2 squared. Okay, then there's a plus 2. That is my f of x in here. Okay, then from there, there is a minus 2 here. Then after that, we are squaring. The whole of this is my f here. You see that? Okay, then plus the 2 here, then I will equate this one to 29. Now, this one will disappear. Okay, so if it disappears, then that means we are going to have this square here will be put on this 3, we get 9. Then 9 times 3, that is a 27. So we shall have 27. Then this square this one here, it becomes power 4. So x minus 2, then to the power of 4, then which is equal to, take this one this side, it becomes a minus. So 29 minus 2, that one gives us 27. Do you see that we can divide all through by 27 and it disappears? That means we shall have x minus 2, then to the power of 4, which is equal to 1, okay? Then the fourth root, remember, whenever you take the fourth root, that is a plus or minus, okay? Because even power of a negative is also a positive, okay? Now, x is therefore going to be equal to 2 when it crosses, because it is a negative, so now it is a positive, then plus or minus. Fourth root of 1 is, of course, 1. So meaning x1 is going to be equal to 2 minus 1, which is a 1. And then x2 is going to be equal to 2 plus 1, which is a 3. But not all of these two values, we are going to take them. Now, we saw that f here is valid for x greater or equal to k, or x greater or equal to 2. That means the value of x we are going to take has to be the one that is bigger or equal to 2, and has to be this 3 here, okay? So in my conclusion, I will say since x is greater or equal to 2, okay, then x here is going to be equal to 3. As simple as that.